Concentration of ores. Removal of the unwanted materials, example sand, clays, etc., from the ore is known as concentration, dressing, or benefaction. Ores which are mined often contain many impurities. These impurities are called gangue. First of all, concentration is done to remove impurities from ores. Concentration of ores is also known as enrichment of ores. Process of concentration depends upon physical and chemical properties of ores. Gravity separation, electromagnetic separation, froth flotation process, etc. are some examples of the processes which are applied for concentration of ores. Some of the important procedures are described below. Hydraulic washing. This is based on the differences in gravities of the ore and the gangue particles. It is therefore a type of gravity separation. In one such process, an upward stream of running water is used to wash the powdered ore. The lighter gangue particles are washed away and the heavier ores are left behind. Magnetic separation. This is based on differences in magnetic properties of the ore components. If either the ore or the gangue, one of these two, is capable of being attracted by a magnetic field, then such separations are carried out. Example, in case of iron ores. Magnetic separators are used in factories. Materials are put on a conveyor belt that is spun by magnetic wheels. As the objects are moved upside down, the non-magnetic objects fall off and the magnetic ones stay on. Froth flotation method. Froth flotation is the scientific process in which valuable metal ores are extracted from sand and rock. An example of this is ore and sand, which are inseparable by themselves. But if some kerosene is added to this mixture, they are easily separated. This works because the ore in the sand is soaked up by the kerosene, and if the mixture is shaken, the kerosene will float to the top of the water. The froth on the top can be skimmed off. Lead, zinc, and copper ores can be separated from gangue using this process. Leaching. Leaching is often used if the ore is soluble in some suitable solvent. The following examples illustrate the procedure. Leaching of alumina from bauxite. The principal ore of aluminium, bauxite, usually contains silicon dioxide, SiO2, iron oxides and titanium oxide, TiO2, as impurities. Concentration is carried out by digesting the powdered ore with a concentrated solution of NaOH at 473 to 523 K and 35 to 36 bar pressure. This way, Al2O3 is leached out as sodium aluminate and SiO2 as sodium silicate, leaving the impurities behind. Al2O3 plus 2NaOH plus 3H2O gives 2NaAlOH4. The aluminate in solution is neutralized by passing CO2 gas and hydrated Al2O3 is precipitated. At this stage, the solution is seeded with freshly prepared samples of hydrated Al2O3, which induces the precipitation. 2NaAlOH4 plus CO2 gives Al2O3 x H2O plus 2NaHCO3. The sodium silicate remains in the solution and hydrated alumina is filtered, dried and heated to give back pure Al2O3. Al2O3 X H2O gives 1470 K Al2O3 plus X H2O gas